All right, so the time has finally come for me to design and install a secondary electronics board for R2. Now you might be thinking, why bother with the secondary board when I still have room on my primary board? Well, there's a couple of reasons for it. First of all, when I implemented the primary electronics on R2, my goal really was just to get him moving. I didn't want to overcomplicate things, and so I didn't even really consider what I would do in terms of where I would put all of the body electronic stuff. And secondly, from a matter of convenience, when you really think about it, just about everything that R2 does below the neck is going to be along the front of R2. He's got his utility arms, his doors, lights, the gripper arm and interface arm, and all of those things then would need to be connected back to the main electronics board. And one of my goals was really to make the main electronics board easy to remove in a pinch. And so having all of those extra connections would really kind of defeat the purpose of all that. So I thought a smarter approach would be to create a secondary board located elsewhere in R2 that I could connect with a single power and signal umbilical. But then, of course, the question becomes, where do you put it? There isn't a whole lot of space in R2. But there is one spot that I thought might be a good option, and that's on the right-hand side, below the charge bay, between the speakers and the right shoulder. Putting a board there would give us easy access to everything in the front, and it wouldn't block access to anything else that's important. So the next step after deciding that that was a possible place was to dive into Fusion 360 and see if I could design some sort of a mount system. All right, so the first thing to do for this is, as a Battley Patreon, I do have access to his Fusion 360 files, so I could import the relevant body section and then slice a quarter out of it so I have something to work with to make sure that the parts that are going to interface with the body are going to be an exact fit. Then I'm sort of positioned and modeled in where I kind of guessed an electronics board was going to be, and kind of played around with the position a little bit. I had to be sure that it was going to clear that little junction there on the right to make sure that the board could be resized if necessary, and make sure that it was going to be easy access from the top. Once that was done, then I started getting creative in coming up with a bracket. I knew I was going to have 4 magnetic standoffs that would hold the board relative to the body. And so by modeling those and using the body itself to slice the ends of those standoffs, this should be a perfect fit. And the bracket would be attached to the board, the standoffs attached to the body, and just as an added benefit for installation, I did end up keying each type of standoff so that it would be positioned and oriented correctly. I think this is going to help when I go to install this in the body. I'm just going to have everything magnetized together, and I will epoxy all 4 of those standoffs onto the body at the same time. And let's see how the print files came out. Well, and after a handful of iterations, this is where I've ended up. I have the bracket and the standoffs just attached to another foam board prototype for the electronics board. The standoffs themselves are held in place with these 20 millimeter diameter magnets. They're pretty thin, but they should be strong enough, I would think, to hold this into place. And my thinking being that with these things magnetized into place, I can simply slide this in and epoxy it into its final location. The nice thing with the size of this is that it actually will fit right through the speaker opening and should be able then to just get it right into place like that. Hard to do with one hand holding the camera. But yeah, I think this is going to work. We'll see how it goes. Well, of course, it wouldn't be droid building if you didn't have to go back and change something that you did before. In my case, once I decided where my secondary board was going to be, I realized that the spare connector that I had left on my main electronics board, which is currently labeled aux2 there, was kind of on the wrong side of R2, diametrically opposed to where the board was going to be. And so rather than snake an extra long umbilical, I did decide to add an additional auxiliary connection down here, which is much more appropriately located. And you see that I've also now run an additional connection from the Arduino. This will eventually connect to the body Markduino, and that there is that leftmost pin there. That's the serial 3 connection. So both of these are actually fused, and right now they're on the 24 volt side of the equation. And you might also be wondering why 24 volts and why not 5? And that's a really good question. Right now, there is nothing that's going to be on my body breakout board that is going to run on anything other than 5 volts. So I certainly could have just created a fused 5 volt connection. I still have 2 slots open on my fuse block. And use that. But for reasons I'll get into in a future video, I do hope to eventually be able to make good use of my full battery voltage at that location. So for now, I'm going to be running a fused 24 volt power line as well as the data line to the board. Which brings us to here. I teased this a little bit about a week or so ago, but this is the fully functioning prototype of the secondary electronics board. Right now it's running off of my bench power supply, and I'm passing it 24 volts. That is being fed in down here in the corner, and then it is being passed to this guy here. This is a combination voltage regulator and power distribution block that I designed. I was inspired by Ross D over at Astromech, who combined the two. It's a nice small footprint way of combining both of those. So I have that taking the 24 volts down to 5 volts, and then I have that powering 3 different components. The first is the body Markduino, which the flashing light shows that it's functioning, although it's not receiving any commands, and I'm going to need to customize the code in order to get any of that to work. The second item is my charge bay and data port lights. These are from Glenn Harper's run on Astromech. And one of the nice things about them is you see these 2 DuPont style connectors there. This set of lights includes jumpers, which are by default installed so that the lights are always on. But the jumpers allow you to insert your own switches. So in this case, I have these magnetic switches here. I've already embedded a magnet in the door, and I'll be posting a video detailing this more specifically. But if you take the magnet away, the lights come on. And put the magnet back, and the lights are off. Likewise, the same thing would happen over in the charge bay. Take the magnet away, and the lights come on. Now the 3 lights that you see there that are not on, that's the aspect of this build that I'm going to want 24 volts eventually. It's sort of a rudimentary battery level meter. It measures voltage and indicates red, yellow, or green based on your battery voltage. Right now I can't hook that up because I don't have a 12 volt converter, and my board by default was set up to 12 volts, not the 24 that I need, so I'll have to figure out something for that. And then the last component that I have is this wireless relay, which, as I showed in my little video last week, is connected to this key fob, and I'll be posting a video on how to hook this up a little bit later too. But this is the trading card dispenser designed by Jaffa 007, aka James R5D4, and you just press the button and hold it, and out comes the trading card. So I still need to design a mount for that so that it can go behind the large data port. But yeah, I think this is at the point where the next steps are for me to convert this over to a final board and get everything installed into R2. I will install those magnetic switches, and then once those are done, then I get to start having fun with Markduino code. So thanks for watching, and I'll talk to you guys soon.